Hi folks, my name's Steve Watt. I work for Red Hat, which is an open source software company. That was a great prelude to a lot of the things that I was about to talk about today. I'm a Kubernetes contributor. I work specifically in the storage and multi-cloud space. And I'm also a contributor to the CNCF storage working group. So I want to sort of try and find a basis from which to sort of reason up from. And I thought a good place to start was, over the last 10 years, the enterprise software architectures have seen a huge shift from scale up to scale out. Now, I posit this is largely driven by big data and performance and capacity requirements, but it's also sort of driven a shift to also using open source software. And so, as part of this, when you look at sort of from the storage dimension, what we have today is that we have scale up and scale out storage appliances. And so just to reset a little bit, like when I say scale up, what I'm talking about is you run an application on a server, and when your application is starting to run out of capacity, you buy a bigger server. And when it runs out of capacity again, you buy yet another bigger server. And what happens is just you start running out of the ability to scale linearly that way. And so when you go scale out, what happens is as you need more capacity or performance or resources, you add another server, and you have a much better chance of scaling linearly in that architecture. And so you have these scale up and scale out appliances, and I'm going to position this against software-defined storage in a second. But an appliance, a great way to think of that is your microwave, right? It's a single-purpose thing. The hardware and software are built and designed with each other in mind. It's usually got a fantastic user experience because it's built for a sort of narrow set of uses, but it's very hard to repurpose, right? You can't take your microwave, change the software on it, and turn it into a fridge, or something to that effect, right? And so in the way the industry sort of historically has worked is you have these storage appliances, and you have a storage admin that will then go and use either a user interface or a command line interface to go and provision a volume, some storage for a developer. And this is how it's been for a long time. And now we have sort of software-defined storage, which is basically is a very similar model as far as how the admins and the developers interact with it, but the actual fundamental infrastructure has changed in that the storage platform is just software. It's pure software. And the infrastructure underneath it is commodity infrastructure, which is usually x86 servers. Now, what's awesome about this is that if you could sort of buy a single software-defined storage product, and if you wanted to, you could buy like rotational media because all you care about is archival or just a cheap way to store data. But maybe if you're going to put a transactional high-performance system on it, you can put like SSDs behind it. And you have that choice as sort of a slider to sort of really configure your infrastructure to suit your needs, right? And so that's a classic difference between appliances and software-defined storage is that appliances are more custom, purpose-built, a niche application where software-defined storage is much broader. But the other thing is it's more programmable, right? So you can sort of configure the software to do more things. But when we sort of step back and look at this, by and large, the storage industry sort of missed this memo, right? Because beyond just moving from scale up to scale out, there was also this other big shift in the last 10 years, which is shift to public cloud, right? And if you look at how storage is consumed in the public cloud, you have EBS, and if you want to, there's an API, and developers can just go and provision their own EBS disk if they want to, right, or on Amazon or Google Persistent Disk, etc. But on premise, you really didn't have this, right? What happened was the developer had to somehow communicate to a storage administrator, please go make me a disk, right? And sure, you have other platforms like OpenStack that have Cinder and things like that, which automate that. But by and large, it's more of an administrator-driven thing rather than developers having direct access to it. And so what you ended up with was, storage admins that by and large were sort of happy and developers that were kind of sad. And so what's happened is that innovators started adding service interfaces to their storage platforms. So in some sense, they made their storage platforms, their software-defined storage platforms, microservice-like, except they're a little too big to be called a microservice, but it's still that sort of service-based consumption model. And the way things changed is that the storage administrator didn't go away, but what they had to get involved in changed, right? And that they were basically like Dave, the storage administrator, just simply sets quotas for Sally, right? So if you know, Sally's only allowed to consume X amount of storage capacity or provision Y amount of volumes, Dave sets that, and then Sally can just go ahead and provision that directly from the storage infrastructure. And this is way more productive, right? And very easy to sort of build applications. This is sort of true programmability. So my point one is, as far as we look at sort of how software-defined storage is going towards the future, is that developers will be a little more joyful, and software-defined storage platforms will become infrastructure services, right, accessible by developers via API. Now, just to change tack a little bit, there's a separate set of problems that are more on the administrative side that I think we're going to see more of a change on. And so now that your storage platform has a service interface, it becomes a whole lot more like, you know, all your other modern data management applications that you're building applications on, right? So, you know, Gluster is a software-defined storage platform. It has a service interface called Hekedi on it, and actually the way you interact with Gluster, the way you deploy Gluster looks a whole lot like Mongo, Cassandra, et cetera nowadays. And so this creates a different problem now, because when you're building applications, you have all these different clusters that you now have to manage, right? So you've got your 20-node Gluster cluster, your 60-node Redis cluster, your 200-node Cassandra cluster, and your 140-node HBase cluster. And so each one of these, you have to learn how to like deploy it, how to scale it, how to manage it, et cetera. And furthermore, you're paying for infrastructure for all of this, right? So a great useful statistic to keep in mind is that if you buy a rack server for about $300,000, right, it costs you about $100,000 per year to power and cool that thing. That is astounding, right? And it's especially bad when you consider that the industry standard for server utilization is like 15 to 20%. So you're paying all this money for all this infrastructure that you're not really consuming. So this is making your data center admin sad. And so the cool thing about all of this is that these platforms is that they're all just software, and that you can do all these amazing things with them that people are doing with software. And so the first is like packaging and deploying your storage platform as a container. And so what's cool about this is that all the scale-out software, which a lot of it is open source, is usually quite complex to deploy consistently. And so when you move those platforms into containers, you can actually bring in a lot of the environment that the process needs to run. And so when you start the container, at least at the node level, that everything is running like it should be, and it takes a lot of that deployment complexity out. But the other wonderful thing is that you can, once you take your application and package it for a container orchestrator like Kubernetes, then Kubernetes does a lot of wonderful things for you. Deploys your application across the entire cluster. It can scale your application up, can scale your application down, and it can handle failover. And most importantly, you can take all these different clusters and run them all on the same set of infrastructure. And this is revolutionary, especially because now what you're doing is you're running your software-defined storage platform as an infrastructure service alongside all your other application platforms. So this has got a number of benefits, right? Obviously, you have the potential to greatly reduce the amount of clusters you're running, but also, you've got the cost savings for, not having to do all of that. But now you've got a single control plane. And I would posit, right, so I'm going out a bit on a limb here, but these talks on the future of stuff aren't fun if you don't make some interesting predictions. But I think that what you're going to see for all these clustered-based platforms is they're not going to have to do scale up, scale down, failover, deploy anymore. They'll defer that to Kubernetes. And so they won't need to focus on those things. And I think you're going to start seeing that code moving out of those projects. And so this is really cool. And so this is my sort of final point, is that software-defined storage platforms will be containerized and deployed by a container orchestrator as infrastructure services alongside microservices. And this is sort of the future we're building at Red Hat, right? So we got way in front of this. We're the ones innovating on this space. We're the second largest contributor to Kubernetes. And we have OpenShift, which is our enterprise Kubernetes distribution, and Container Native Storage, which is our software-defined storage product, running as an infrastructure service inside OpenShift. Thank you very much.